LT2A, solving one-step equations. Understanding equations. An equation is the statement about equality of two expressions. Now, equality means that we have an equal sign. And all equations can either be classified as always true, never true, or sometimes true. So we have expression 1 equals expression 2. For example, 1 plus 4 equals 5 is always true. One plus 3 equals 6 is never true. And x plus 3 equals 5, well, that depends, right? This is sometimes true, depending on what x is. So when we are solving an equation, what we're really trying to do is find the values of x that make the equation true. We want to get plain old x by itself. And so the way that we do that is we can ask ourselves what has been done to the variable, and then what can we do to undo. So first of all, solve equations using addition and subtraction. Exercise 1, list the operation that has been done to x, and then solve the equation by undoing that operation. So exercise A, we have x plus 6 equals 3. So what happened to x? Well, it was added by 6. So the inverse or operation of adding 6 is to subtract. So to undo, we will subtract 6. Seems pretty simple because this is more of a review lesson, but it really is fundamental to succeeding in this class. So here's the original problem, and the inverse operation is to undo. And so our solution for this one-step equation is -3. Moving on to part B, m minus 3 equals -5. So what happened to x? It was subtracted 3. So the inverse operation is to add 3. So the original problem, m minus 3 equals -5. The inverse operation, add 3 to both sides, which gives us m equals -2. Now for part C, we have 4 equals x minus 3. It doesn't matter that x is on the right side of the equation. Problem is still done the same exact way, right? What happened to x? Well, it was subtracted by 3. So how are we going to undo it? We'll add 3. So here's the original problem. 4 equals x minus 3. And our inverse operation is to add 3 to both sides, giving us 7 equals x. And we'll go ahead and skip part D. Okay, next up we'll be dealing with multiplication or division. So the strategy here is it depends on what type of number we're working with. But a quick detour that I want to take us on is to talk about the idea of reciprocals. So a reciprocal is what happens when you take a fraction and you flip it. So off to the side, I'll write the original fraction is, say, 3/5. The reciprocal is what happens when you flip the fraction. Occasionally, you might see me do a loop-de-loop. This is not a real math symbol, but I would like to draw this loop symbol to remind myself that I'm taking the reciprocal. And the reason why the reciprocal is so useful is because when you take a fraction and you multiply by the reciprocal, what ends up happening is all of the numbers are going to reduce each other. For example, if you take 3 over 5 and you multiply by the reciprocal 5 over 3, notice what happens is I have a 5 in the numerator and I have a 5 in the denominator. These will reduce each other, turning into 1s. I also have a 3 in the numerator and a 3 in the denominator. Those will reduce each other, turning into 1. Why is this helpful? Well, this is really 1 over 1, or just 1. And what's great about this is that since for solving equations, we're trying to get x variables by themselves, if you see a number that is attached to the variable as a coefficient, if you multiply by the reciprocal, that will then get x by itself. So here's what I mean. Exercise A, 3x equals 5. So what happened to x? Well, it's being multiplied by 3. Now, normally, in order to do the, quote, opposite operation, the opposite of multiplying is dividing. But rather than dividing, what I'm going to highlight is the strategy that what we can do is we can multiply both sides by the reciprocal of the coefficient. So here's what I mean. Instead of leaving this as multiply by 3, I'm going to write this as multiply by 3 over 1. So the opposite operation of multiplying by 3 over 1 is dividing by 3, but we can actually think of it as multiplying by 1 over 3, the reciprocal. Why are we doing this? Well, here's my original problem, 3x equals 5. Here's my inverse operation, multiplying by 1 over 3. And what's going to happen? Well, since I have fractions in the problem, we can turn everything into a fraction. Now on the left-hand side, because I have a number multiplied by the reciprocal, everything is automatically going to reduce to a 1. And all we're left with is x on the left-hand side. On the right-hand side, I have 5 times 1, which is 5. And on the denominator, I have 1 times 3, which is 3. So the solution is x equals 5/3. Now this might seem like extra work compared to just simply dividing both sides by 5, but you'll find that when we get to more complicated fractions, like the ones in the problems below, this idea of multiplying by the reciprocal will make you significantly quicker at doing mental math and saving a lot of time. So part B, we have x over 5 equals -6. So for a problem like B, I want you to get used to thinking of this as 1 over 5 times x equals -6, right? Usually what's happening is because 1 times x is simply x, we can write the x in the numerator. And you don't have to write it as fraction times x every time, but some of you do need that as a tool. So what's happening to x is it's being multiplied by 1 over 5. So we can either think of So the way that we can undo this then is to multiply by the reciprocal. So to undo it, we'll multiply by 5/1. Let me write that neater. So here's the original problem. X over 5 equals -6. Here's my inverse operation, multiplying both sides by 5/1. We'll also turn the -6 into a fraction. On the left-hand side, a number times its reciprocal reduces to 1. So all we're left with is x equals, and then on the right-hand side, we have -6 times 5, which is -30, all over 1, or just -30. Moving on, we have 3/5 x equals 10. So what happened to x? Well, x was multiplied by 3/5. And so this is where the shortcut really comes into play. In the old method, the opposite of multiplying is dividing, but then dividing by a fraction is always nasty. If you're doing it my way, the way that we can undo multiplication by 3/5 is we can multiply by the reciprocal, which is 5/3. So the original problem is 3/5x equals 10. The inverse operation is to multiply by 5/3. So we do that to both sides. And since I have a fraction times a whole number, let's convert the whole number into a fraction by putting it over 1. On the left-hand side, number times its reciprocal will reduce to 1. So all we're left with is x is equal to, on the right-hand side, 10 times 5 is 50 in the numerator, and in the denominator, 1 times 3 is 3. Okay, part D, we have 2/3 q equals 1/2. So what happened to q? Multiplied by 2/3. So the inverse operation is to multiply by 3/2. So we have 2/3 q equals 1/2 is the original problem. The inverse operation is to multiply by 3/2. So on the left-hand side we have q, and on the right-hand side we have 1 in the numerator, 1 times 3 is 3, and in the denominator, 2 times 2 is 4. Part E, we have 2 equals -x. So this will happen occasionally where we have x is being multiplied by so whenever you have a negative sign in front of a variable, there isn't just a negative sign, but there's actually an invisible one. So I'm going to write that in. Oops, I'm going to use red for that. So whenever you have a negative sign, in front of the negative sign is also a 1. It's just math people are really lazy to write it in, but it is there. So what's really happening is it's being multiplied by a -1. So from here, the inverse operation is, because we just have a simple whole number, usually teachers will say, hey, divide by -1. Alternatively, you can also simply multiply by -1. So here's what the work will look like, because there are technically 2 different ways to go from here. 2 equals -x. If you want to divide both sides by -1, this gives you -2 equals x. The other way that I've seen it done is, here's the original problem, 2 equals -x. You can then multiply the left-hand side by -1 and the right-hand side by -1. And so -1 times 2 is -2. And then -x times -1 is x. Notice that the solutions are the same. So you can use whichever method you're more comfortable with in this case. And lastly, we have f (-x/3) equals 4. So what's happening here is, if I rewrite the problem so that it's (-1/3) x equals 4, we can see that x is being multiplied by (-1/3). So what is the inverse? Well, the inverse is to then multiply by 3/1 with the negative sign in the front. So notice, for the purposes of reciprocals, whatever the sign the original number has, the reciprocal has the same exact sign. Okay, so here's the original problem. (-x/3) equals 4. The inverse operation of multiplying by (-3/1). Okay, on the left-hand side, now what will happen is 3/1 times 3 is 1. And then because we have a negative times a negative, it's going to be simply x. And then on the right-hand side, we have 4 times -3, which is -12. And that's it.